Hey everyone. The actual topic of my call, my talk is actually improving trade execution in MEV, or as some people like to call it, MEV. But really, the answer is MEV commit. And here I'm going to dive into it. MEV commit's been something we've been developing for a while and been architecting and talking to lots of researchers around the space for a while about. And I'm happy to present it to you here. Now, before I do that, a little brief intro about myself. I was the former product lead at Block Native, and pretty much almost the entire MEV industry either used some of our services or products, and we were one of the top block builders as right after the merge last year. And a lot of my dealings were with MEV searchers who are actually coming up to us and saying, hey, look, you're a top builder, we love using you, but no single block builder can give us next block execution. The most dominant block builder today has about 30% of the network, which means they lose the next block 70% of the time. So it's not really too helpful for you if you're dealing with a major block builder and you want next block execution. So what you end up having to do is dealing with many block builders at the same time, but not in parallel, really just kind of one-on-one. What you really want to do as a user is deal with a network of block builders and other execution service providers. You don't want to deal with each individual service provider. And that's kind of the core idea behind how Primev formed. But essentially, I launched Mempool Explorer in 2020 around DeFi summer. It was the first time that you could see mempool transactions in real time. And it was also an authoring environment with no code that you can do stuff with these transactions. And guess what people did with it in real time? They front ran everybody else. And then you had these gas wars that came up in 2020. And eventually Flashbots came up with MEV Geth, where they started sending transactions privately to miners in order to kind of avoid this mempool wars that were happening because people had access to such data. So the emergence of MEV, you could say, is very parallel to what I was doing at the time, and we kind of had a hand in kind of maybe accelerating it a little bit. But how can we improve trade execution in MEV? Well, the two fundamental problems that cause bad trade execution in MEV compared to centralized exchanges is one, that decentralized systems just can't give the same guarantees that centralized exchanges can give. So what you end up doing is you send what you want into some ether, right? Some mempool or some block builder, and then it lands on chain, and then you found out what happened. And a whole bunch of software and processes may have come in between, but you have no idea. And nobody told you that, hey, you're going to go on chain actually, and this is what's going to happen. It's going to be the way you want, etc. And when you think about the source of liquidity for a lot of our trades and for us to get decent trades and other interactions on chain, is because of high frequency trading firms that are actually sourcing that liquidity off chain and bringing that liquidity on chain. But the problem is, if you're trading on Coinbase or Binance and you make a trade, you buy some ETH, it's going to go through instantly. And then if you have to submit a transaction on Uniswap, it's going to take at least 12 to 15 seconds. Well, the amount of risk you're taking between those 12 to 15 seconds as a liquidity provider pretty much is immense, and there's no way to measure it today. So what you want to do is you want to have some sort of guarantee from the network. It doesn't have to be a binary guarantee that, yes, you're going to get executed or you're not. It just has to be some number. Okay, like 65% of the network has given me a guarantee. Great, I can plug that number in to my risk algorithm, and then I can hedge whatever trade I'm doing on Binance or Coinbase such that I can provide the service efficiently. This is one of the core pieces of the puzzle. And the other thing is, there's just transaction pipelines are very complex. So it's not good for end users or even some MEV searchers to do things as emergent, more complex things. So basically, decentralization and complex transaction pipelines create this ambiguity in execution. So if this is an Ethereum block, there's 3 transactions in it, orange, blue, yellow. You have some MEV searchers represented by these Flashbots icons that are sending transactions into it, and then 12 seconds pass, and guess what? They lost some money on Coinbase or something. They have no idea, and they find out that they're on chain. During this 12 seconds, this is kind of what they feel. 12 seconds is an eternity to trade in, so you just can't afford that kind of level of ambiguity. So we're introducing MEV commit, and we're saying, look, we're going to create a peer-to-peer network that you as a block builder, you as a MEV searcher, you as a relay, you as a proposer, you as a roll-up sequencer can join. And guess what? You can coordinate what you're going to do over here across an increasingly decentralized stack. So today you have these block builders that build the whole block, and at least they know what's going to happen if that block makes it on chain. Well, tomorrow you might have a relay where the block builder builds 80% of the block, the bottom of the block. The relay might append its own block on top of it. Well, guess what? You want some guarantee from that relay that it's not going to screw this block that you've built, right? And for that, you need a coordination mechanism. So through this peer-to-peer network, the relay and the block builder can actually engage in commitments such that the block builder has better expectations as to what this relay is going to do when they receive their block. So that's kind of the core kind of coordination layer that MEV commit enables. As a peer-to-peer network, you can coordinate across the pipeline and stack such that even though you're upstream in the pipeline, you have guarantees downstream in the pipeline that they're not going to screw over your trade or do something that was unintentional. So we've separated MEV commit as this kind of lightweight piece of software. And what it does is it gives the ability to publish these credible commitments. We have some cryptographic primitives in there using time lock puzzles such that you can be in an open network with a whole bunch of people, but issue a private commitment to the user that you're trying to give it to, and then everybody else sees that you've committed to something, but they don't know what it is during the intra-block period. And by the time the block is on chain, then the time lock puzzle is open, and then everybody can see that actually indeed you had committed to this, such that some value can settle related to that, whether that's a bid amount or some slashing. But essentially, we've kind of abstracted MEV commit from what's going on in the core of Ethereum, which is EVM transactions, things of that nature, and you can engage in all sorts of execution games with it. We think the market will evolve such that execution games will actually have some market share, and different entities will own different types of execution games, but that's yet to be seen. So this is kind of above the diagram is kind of how Delphi Research and Flashbots kind of thought of how to represent the actors in PBS. And we're really building MEV commit to hook up to a lot of these actors and allow them to kind of coordinate on different things. We think the need for it is fairly large, but we think it's going to increase as different pieces of the stack gets decentralized and block building becomes increasingly kind of towards partial block building and additive block building, such that for the actual block, you're going to want to coordinate with some of the others that are building the rest of that block. So to summarize things, it's a P2P network for all MEV actors, and then you have some privacy-preserving credible commitments that allow you to do things in real-time intra-block with the folks that are providing you those services, but other people can't really see them until they're kind of relevant for everybody to see. So here's a chart from EigenFi, I believe, that kind of puts some dollar figures from January and February of this year on MEV pipeline. You see this kind of pretty much $48 million go down this funnel, and every piece of the stack, on chain at least, makes some money from this pipeline. What's invisible here is two things. One, the amount that the searcher actually makes off chain, which is not seen, because if you look at on-chain data, you see MEV goes to validators. Well, guess what? Most of the MEV actually goes to people on Coinbase, people on Binance. You just can't see that on-chain. And the other thing is relays are missing here. They don't have they're not making any piece of the puzzle or the piece of the pie. And we think as this stack decentralizes more and more, relays are going to have an increasing role, and then they're going to want to use software like MEV commit in order to coordinate things better with the rest of the stack. So yeah, there's pretty awesome things coming on in this ecosystem that increase the complexity across the transaction lifecycle and increase decentralization. And we believe these lead to coordination and efficiencies across actors, such that a peer-to-peer network like the one MEV commit establishes is going to be very integral to coordinate people for. This is an AI-generated concept of how we envision our network. Basically, some robots are able to look into blocks and able to do things before the blocks are actually final. And we're pretty excited about this future. We're very early in our journey, but we're working with some of the best folks across the ecosystem in empowering their pieces of software to perform better, to be more prominent pieces of the MEV pipeline. And we're very excited to get this to market. There's an alpha on our GitHub. There's going to be a beta very soon that a lot of people are already looking at and starting to play with. But yeah, you can anticipate your favorite MEV infrastructure provider to have an opinion about it at the very least. So yeah, this is Primev. We're building MEV commit. Thank you very much.